Welcome back to Judgment Decision Making. I'm Dr. Padilla. Now we're going to begin a discussion of empathy. Question for this section of the course is, when does empathy lead us to actually do something helpful? And when we do act, who benefits from that action? Are we actually doing something empathetic, or are we secretly benefiting ourselves in some way? Now, the first place to start has to do with this sensio-motor connection. This concept that when we see someone poked with a sharp needle, we actually evoke a sensation of pain or activate the areas in the brain that can sympathize with individuals. And it is based on the way that we've evolved. And it's illustrated nicely in this rubber hand illusion that indicates you can actually project your feelings of sensation onto inanimate objects.
We're going to do a little demonstration here called the rubber hand illusion. It's going to be a little scary.
This illusion may look like fairground fun, but it reveals one of the most important new ideas in brain science.
Thank you. Right there. Good. And can you put this hand down right over here and just curl it up like the rubber hand's curled up a little bit. All right. Now, what I'm going to do is try to position the rubber hand so it looks like it's your own. Okay, could you imagine that being your own hand, kinda?
Yeah.
What we're going to do is we're going to stroke your fingers simultaneously, the rubber finger and your real finger, and hopefully this will convince you that the rubber hand is your own, that your brain will actually adopt this hand.
In the illusion, simply watching the rubber hand being stroked at the same time as the real hand is enough to trick the brain into adopting it as its own.
We like weird. And slowly but surely, you should feel that the hand you're looking at is actually part of your body.
Feels like you're touching my hand with that one.
Right, so it feels like this is your hand that I'm touching, right?
Yes.
So what might be going on in the rubber hand illusion is that the brain is actually changing to accommodate the new rubber hand, going through some sort of, structural change that we call neuroplasticity.
Neuroplasticity is an exciting new idea that suggests the brain can change in response to experience. And this is what's taking place in the rubber hand illusion. The brain may be temporarily rewiring itself to adopt the plastic hand as its own.
Okay, I think that was a really interesting example, and it demonstrates how our brain is really wired to be able to imagine the perspective of others and feel things that we see. We'll talk more about the neuroscience around why that functions in later lectures, but suffice to say, on a very basic level, when we see someone in pain, we activate areas of the brain that are also indicated with pain. Now, beyond that, we also develop mimicry, which is a cornerstone of social learning. And this is a skill that we develop. So I'm going to play this short video, and I'd like you to watch how this baby Nala mimics extraneous movements in addition to the sounds that her father is making. I note that the monkeys in lab studies only mimic the task-related activities and not the extraneous movements. So we as humans are master mimickers, and we mimic every part of an action to try to get it right.
Can you say hi? Hi. Yeah, g'day and welcome to this instructional video on how to teach a toddler to sing. This is my 2-year-old Nala. Right, are you ready?
Yeah.
Okay, so basically you just need to cover like the music fundamentals. So first, can you go ah, 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 Okay.
Very cute. So I'm sure you saw that she was trying to mimic the sound, but also the facial movements and the body structure to match her dad as well. Now, this mimicry and social contagion are really just baby steps. Do other animals actually feel others' pain? And there's one study that demonstrates a mouse would observe another mouse separated by plexiglass in pain, and as a result, its own pain sensitivity increased. The amount of pain a mouse was feeling was actually modulated by the amount of pain and by the nearby mouse. Importantly, this was a social phenomenon. The shared pain only occurred when the mice were cage mates, indicating that the mouse had to know the other mouse in some way in order for its personal feeling of pain to be modulated by the level of this cage mate's pain. Now, here are some examples of species trying to proactively lessen the distress of another. And this is just a really cute video, not cute, but interesting video of a bear who seems to be saving this bird here. And the question really proposed throughout this chapter is this bear and do other animals, including ourselves, are we sincerely trying to help others, or are we helping ourselves in some way? And it's kind of hard to disentangle that. But with animals, we see reconciliative behavior, where after a fight between two animals, they will get together and they will show higher than chance levels of affiliation behavior, indicating that they're a part of the same group. That can be grooming or sort of being in a space with one another. And the thought is that action happens in order to avoid fights in the future. We also see consolation behavior, where when two animals were in a fight, then another animal will comfort the victim of the fight. It's not necessarily the one that lost, but the one that was not the aggressor, meaning that animals have to in some way keep track of who was the perpetrator and who was the victim, and then they try to support the victim in order to make them feel a little bit better. And this happens in wolves, elephants, dogs, covids, and many others. Now we also see that rats work more, they essentially press a lever more to lower a distressed rat dangling from the air in a harness than a suspended block. And rats proactively work to release a cage mate from a stressful restrainer, and subjects were motivated to do this as much as to get chocolate. So that's to say that they really were trying to help their distressed cage mate in both of these circumstances. And again, the question is, are they really trying to lessen the pain of the rat that's in the next cage or dangling from a harness, or are they trying to make the rat be quiet and reduce their own amount of discomfort? Okay, and so let's think about how this functions in children. Again, a cute video of a baby comforting a Labrador during a thunderstorm. And with children, what's interesting is that we can actually have some indication of the evolutionary arc of how empathy has developed based on child development. At very early stages of child development, young children, you're seeing this base level where when they see another's pain, they get a sort of areas of their brain that are activated with pain. That's a very low level version of that. But when they start to develop a little bit more, they begin to develop empathy states. And this triggers the more emotional states of the brain that we've learned more about. And that's areas that have more recently developed in humans. And then finally, when they begin perspective taking, where they can imagine themselves in someone else's position, then the areas that are more related to higher order cognition are activated, like the VMPFC, those sort of deliberative areas that we've talked significantly about. And that actually maps the development of the human brain as well. So you can kind of see how these two things mimic one another. Summary here, when individuals in pain, we, humans, primates, and mammals, are often induced to be in a state of pain as well. Evolution plays a role in the development of this, and this can be seen in the development of children's empathy. So if you have a young child at home, you can begin to watch how their empathy grows and have an indication of how that happened evolutionarily as well.